Today we're going to look at some notes from section 5.1 and 5.2. Now we've already gone over the unit circles, so we know what a unit circle looks like, and we've put the degrees and the radians on it, so we know those kinds of things on the unit circle. So we're going to be using this key, the one that you had, that I gave to everybody, or that you could print out from your computer. So we're going to be using that key some of the time, so we might want to make sure you pull that out. So the first thing we're going to look at is what quadrant theta, now we said theta was the name of an angle, is in, what quadrant theta is in if theta is, and so I'm going to give you several choices. A, you're going to tell me what quadrant 150 degrees is in. B, 2 pi over 3. C, 11 pi over 6. And D, 240 degrees. So all I want to know is what quadrant. Now, if I were you, what I would do is I would draw a little unit circle. And now you got to decide, where is 150 going to be in this little unit circle? So that's what you're going to do on those. So my unit circle is going to make this come out to be where, if you look on your unit circle, where is 150? So 150 is over here in quadrant 2, 150. Okay, 2 pi over 3. We know it's got to be somewhere in quadrant 1 and quadrant 2 because this would be 3 pi over 3. So 2 pi over 3, this would be 1 pi over 3, so 2 pi over 3 would again be in what, quadrant 2. (11 pi over 6, we know is almost back to our starting point again. So it's going to be here, which is quadrant 4. And then 240, if you look on the unit circle, is between 180 and 270. So between 180 and 270, then is going to give us quadrant 3. So it helps that you know the unit circle. That's one of the things that we said that we wanted to make sure we all learned how to do. Next question is, what is the reference angle? So we're going to look at A, 7 pi over 6. Now we said the reference angle is going to have something to do with going back to the x-axis. So we know angles that are going this way, which would be counterclockwise, are going to be positive. And angles going this way are going to be negative. So we're looking at a positive 7 pi over 6, which puts us over here. So the reference angle is the angle that's, you drop it to the x-axis. So here we would drop it to here to the x-axis. So we would be looking at pi over 6. So always go back to the x-axis. Okay, let's try another one. B, 225. So where do we know 225 is? Between 180 and 270, so it's quadrant 3, right? So 225 would be over here. From here all the way around to there. Now, our reference angle is going to be going back to the x-axis. So this is 180 degrees, and this is 225. What do you know is the difference between 180 and 225? 45 degrees. So our reference angle is 45 degrees. Now we keep talking about all these angles, and we talk about trigonometric functions. So now we're going to look at that idea as what is a trigonometric function. One thing before I leave this part about reference angle, if you look on page 405 of your textbook, it gives you some examples of reference angles. Okay, when you were in geometry, you had trigonometric functions. Trigonometric functions. When you started them out in a right triangle. And you used a saying, SOHCAHTOA. For this helped us to remember what the ratios were. Now I'm going to put my theta over here, and I'm going to call this y, this x, and this r. Now the reason why I do that is if I think of this as being in a coordinate plane, the y is always going to go up and down, and the x is going to go left and right. R is our slanted side, our hypotenuse. So what we do is we write the three things separately: sine, cosine, and tangent. So the sine, and we're going to write it as S-I-N-E, but its abbreviation is S-I-N of that angle, theta, equals opposite over hypotenuse. So the O stands for opposite and the H stands for hypotenuse. So looking at theta, opposite is going to be y over hypotenuse r. Cosine theta is going to be the ca, which means adjacent, which means next to, and the hypotenuse. So here's theta, my next to would be the x, and my r. So adjacent over hypotenuse. And third one is tangent. So these are all abbreviations. Sine was cosine is this, and tangent. So tangent, we know, is the TOA, so the opposite over the adjacent. So if I look over on my picture, opposite would be the y, adjacent would be the x, equals y over x. Now, going along with these three, we have 6 trig functions. So we have what we call the reciprocal functions. So what would be the reciprocal of sine? Well, sine's reciprocal is going to be cosecant theta, which means 1 over sine theta. So if sine is y over r, then cosecant theta is going to be what? You can actually look at it several ways. If sine is reversed, hypotenuse over opposite would be one way of doing it, or just flipping this over would be another way of doing it for reciprocals. So what do we get for cosecant? So hypotenuse over opposite. And then y r over y. Secant is the reciprocal of the cosine, so we have 1 over cosine theta. So that's going to be what? Cosine is the adjacent over hypotenuse, so we're going to have hypotenuse over adjacent. or r over x. Okay, the third one is cotangent theta. So cotangent theta is the reciprocal of the tangent. So if we know the tangent's y over x, then we know cotangent is going to be x over y. Now, this is if we're doing it in a right triangle. But how do we go about putting this inside the unit circle? We know that in the unit circle the radius is 1. So somehow we want to get this radius to be a 1. So if I take and make all the radii to be 1, then I get these. So this is the unit circle functions. You're still using the same opposite over hypotenuse, adjacent over hypotenuse, and so forth. So if I start out with my triangle looking like this, where this is x, this is y, and this is 1, because we're making the radius be 1, then what do we have? Sine of theta equals opposite over hypotenuse, y over 1, which is just y. Cosine theta is going to be x over 1, which is just x. Now, one thing I try to help myself remember that these two things are going to be alphabetically correct. So this is x goes with cosine and y goes with sine, because y is later in the alphabet from x and sine is later in the alphabet for cosine. So we have an ordered pair then on our page, say sine of theta comma cosine of theta is going to be my, oops, that's backwards. Let's fix that for cosine sine. We have x comma y, so that's going to be cosine theta comma sine theta. So when we look at the things that we already looked at before in the unit circle, we're going to look up here at the top of the unit circle and we're going to write in the x comma y cosine sine. So we're going to do that up here at the top. So we have cosine theta comma sine theta x comma y. So now that we know that the x is the cosine and the y is the sine, we also know the tangent theta is y over x. But what is y over x? Well, if sine is the y and cosine is the x, then tangent is also, let me write it down here, sine theta over cosine theta. So that's another way that we can look at tangent, sine over cosine. So give everybody a chance to get that written down for a minute. So we said we were going to read some values off the unit circle. So it says no calculators allowed. Use the unit circle to find the values. So we're going to have our unit circle right by us here. Cosine of 2 pi over 3. So we go to 2 pi over 3. So here's 2 pi over 3. And we look at our coordinates, our x comma y. X comma y. So if it's asking us to find the cosine is going to be the x value. So we go here and we take off the x value. So my answer for cosine 2 pi over 3 is going to be equal to -1/2. So So you see what we're doing? Cosine is the x, sine is the y, tangent is y over x. Now, what about those other ones that we had? The reciprocal functions? So we can use the same idea, but once we get it, we would just flip it over to use the cosecant, secant, and cotangent. Now you should have all those written down so that you can compare them. All right, the next one is sine of 5 pi over 4. So we're going to go where? To 5 pi over 4. So we look at our unit circle. 5 pi over 4 is over here in the third quadrant. So 5 pi over 4, it says that we are looking for the sine, which would be the y value for 5 pi over 4 is going to be what? Negative square root of 2 over 2. Next one is sine of 4 pi over 3. So we go to our unit circle and we look up 4 pi over 3. So where do you see 4 pi over 3? Okay, we're still seeing it in quadrant 3. So here's quadrant 3, and here's my ordered pair. So it's asking us to find the sine of 4 pi over 3. So the sine of 4 pi over 3 would be the y value, so we're going to have negative square root of 3 over 2. Okay, so we've done sine and cosine. Let's see about a tangent. So let's move down a little ways. So let's say tangent of 11 pi over 6. So tangent 11 pi over 6, we still have to go to 11 pi over 6. So here's 11 pi over 6. Here's my ordered pair for 11 pi over 6. Now, since you know the unit circle, though, realistically, you could just take this problem here, draw yourself a little unit circle, draw an 11 pi over 6 so that you can see what the ordered pair is going to be. It would be square root of 3 over 2, comma, negative 1/2. So once you know the unit circle, you can look it up. But that's not the answer. The answer is for tangent. So we know that tangent is going to be y over x. So I'm going to have negative 1/2 over square root of 3 over 2. So what is that called? Compound fraction, right? Fraction made up of fractions. But we know it's negative 1/2 times the reciprocal of that. So it's 2 over square root of 3. So the 2's cancel out. So I get negative 1 over square root of 3. Now, can we leave an answer negative 1 over square root of 3? No, we have to rationalize the denominator. So times square root of 3 over 3, which gives me negative square root of 3. Square root of 9 is 3. Okay, let's try another tangent one. Let's do this tangent 60 down here. So again, this would be tangent 60. We know tangent is sine over cosine, or y over x, whichever way you want to look at it. So we have 60 is up here. So our y over x is going to be what? Square root of 3 over 2 over 1/2. So I rewrite it, square root of 3 over 2 times 2 over 1, and the 2's cancel, and I get positive square root of 3. So you getting the ideas? All right, so you guys can finish out that one. Now, what it's going to ask us for here is it's going to ask us for reference angle and terminating ordered pair. So if I give you 41 on page 408, it gives you that you're talking about 11 pi over 6. It wants to know the reference angle and it wants to know the terminating point. So you guys know that just by looking at the unit circle. You got 11 pi over 6. Where's 11 pi over 6? We know it's down here because we know the unit circle. So the reference angle is going to go back to the x-axis. So 11 pi over 6 would be 12 pi over 6, which would be what? Our pi over 6 for our reference. And what is the ordered pair here going to be? Well, we know that this is positive because it goes to the right and negative because it goes down. This is the long, this is the short. So we know it's going to be square root of 3 over 2, comma, 1/2. So you got two answers, the pi over 6 reference, and then the ordered pair square root of 3 over 2, 1/2. Now, another thing I want to look at with you is this positive and negatives, okay? So we know quadrant 1 is positive, positive. Quadrant 2 is negative, positive. Quadrant 3 is negative, negative. And quadrant 4 is positive, negative. Now, because we know cosine and sine is x and y, if x and y are both positive, then that means that all of the trig functions that are in quadrant 1 are all going to be positive. Because tangent is made up of sine and cosine, and then all these are reciprocals of positive numbers, is going to stay positive. So we know that in quadrant 1, they're all going to be positive. Okay, so we've talked about finding how to read things on the unit circle. We've talked about how to find the reference angle. We've talked about how to find the terminating angle. And so one last kind of problem that we're going to look at. Actually, several last problems we're going to use. We're going to use how to find it if it's not on the unit circle. So we're going to use our calculator for that. Not sure if you can see this or not, but this calculator is a graphing calculator. You guys are not supposed to use a graphing calculator. But you can see how this says radians and this says degrees. So the ones that we're going to do are radian measures, so you have to make sure your calculator is in radians instead of degrees. So we'll come down and we're going to enter that. So now everything that I put in is going to be reading it as radians. So how do I know it's radians? Well, if I have sine of 2.2, then as long as it doesn't say degrees on it, then we know it's radians. So we're going to take and push make sure it's in radians mode, which it is, and then we're going to push sine 2.2. Into my parentheses, enter. And so I get 0.80496. Now remember how I told you, I want you to make sure you put that 0 in front of the 0.8. Now, sine and cosine and tangent are pretty straightforward because they're right there given to you on the keys. But now we're going to look at something like cotangent of 28. Well, we know cotangent is the reciprocal of the tangent, so we would write it as 1 over tangent 28. And then we would put that into our calculator. 1 divide tangent 28. So we would have 1 divide, because your calculators are not going to have the fraction button. So 1 divide tangent of 28. Now notice how it put the parentheses in front of the 28. You have to put the end parentheses around it. So we're going to get equals, and I get negative 3.553286. Now, one of the things that we can do on our unit circle is we can look up first what these pi over 2, pi, 3 pi over 2, and 2 pi are going to be in decimal approximation. That would give us an idea of where those angles are supposed to be. So we're going to take our calculator and we're going to take 2 times pi, but we're going to let, since we're just decimal approximating, we're going to let it be 3.14, which would give me what? 6.28. So that would be the decimal approximation for 2 pi. And then we've got pi over 2, so we're going to take pi and divide it by 2. So we have pi divided by 2, 1.57. And then we've got just pi, which would be 3.14. And then we're going to take 3 times pi divided by 2. So we have 3 times pi. And I'm going to go ahead and push equals and then do my divided by 2. 4.71. Now, the reason why I asked you that is one of the things we can do visually on some of these kinds of things is make sure that the sign is correct on them. So if this was cotangent and tangent was 28, we'd have to be able to find out where tangent 28 is, or sine of 2.2. And we would do that by knowing that this was 6.28, this one is 1.57, and so forth going around. Okay, that's using a calculator. So the last thing we're going to look at is Pythagorean identities. Pythagorean identities. So we're going to have our unit circle again. So again, remember what I told you, we're going to use the unit circle a lot. And we're going to put ourselves a right triangle inside the unit circle. So this is my x, this is my y, this is my theta, and this is 1. So Pythagorean theorem in this case would be what? X squared plus y squared equals 1 squared. Because we have the legs, or the x and the y, and the hypotenuse is the 1. But we know that in the unit circle that this x comma y is cosine theta comma sine theta, right? So we can put in the x is cosine. We would have cosine squared theta plus, put the y in, sine squared theta equals 1. And there would be a Pythagorean identity that we could use to solve. So let's say that I have cosine theta is equal to 3 over 5, and it's in the 4th quadrant. Then it's going to ask me to tell y the 3/5. Now, why did it have to tell me what quadrant I was in? Because in each of the different quadrants, you have different positives and negatives, right? So we're going to draw our picture again in the 4th quadrant. This is our x, this is our y, this is our 1. So it still has the same thing, cosine squared plus sine squared equals 1. But if I want to take cosine and put it into this equation, that would help me to find sine. So I'm going to have 3/5 squared plus sine squared theta equals 1. So 3/5 squared is going to give me 9 over 25 plus sine squared theta equals 1. So we've got to get sine squared by itself. So we're going to move that 9/25 over. So I'm going to get minus 9/25 from both sides. So this cancels and I get sine squared theta equals, now here you have to have a common denominator before you can add 2 fractions. So I'm going to get 25 over 25 minus 9 gives me 16 over 25. But that gives me sine squared. That doesn't give me sine, so I have to take the square root on both sides. Now remember, when you take the square root on both sides, you're going to have plus and minus. So I have plus and minus. Square root of 16 is 4. Square root of 25 is 5. So now we've got two choices. We've got a plus or a minus. So we have to decide we're in quadrant 4. So in quadrant 4, is sign going to be positive or is sign going to be negative? Is the y value going to be positive or negative? Well, we can see that it's coming down, so we know that sine of theta is going to be a negative 4 over 5. Now you can do tangent and all the rest of them this same way. Thank you very much.